Welcome to 279W Windows Server Administration Module 8. I'm your instructor, Robert McMillen. Our objectives for Module 8 will be to discuss performance monitoring, processor scheduled options, virtual memory, task manager, event viewers, event logs, performance baselines, monitors, bottlenecks, counter alerts, reliability and performance monitor console. So, performance monitoring and tuning. This is the process of tracking system performance to establish baselines and to identify and resolve problems. When you install a server, you should create a performance baseline to see how the server is performing given its current resources and typical usage. This is very useful for 6 months or a year down the road when you want to see if the server is still behaving like it did when you first installed Windows. Processor scheduling options. This controls how much processor resources are allocated to applications running on a server. You can optimize processor scheduling for the following application types: programs and background services. So when you first install a server, by default, it's going to be optimized for background services. However, a PC is going to be optimized for programs. So why would you want to have one or the other? Well, if you are hosting a server that does file access, maybe SQL Server, something like that, you'll want to keep it as a background services priority. But if you are hosting a remote desktop server, what we used to call a terminal server, then you'll want to switch it to be program priority. So if we go to our virtual machine, we can get into this fairly simply. We just right-click on Computer, and from there we go to Properties, and from here we click on Advanced, and we see our Advanced tab. Click on under Performance, click on Settings, and then click on Advanced, and you'll see by default this is set to background services. If we wanted to have it set for foreground, such as a terminal server, remote desktop server, where Word and Excel and things like that need to have priority, then we would switch it to programs. Virtual memory, used to allow a system to write parts of memory to disk. All servers have an initial paging file. It's created automatically on the drive containing the operating system during installation and setup. The file is named pagefile.sys. The book, in most cases, for computers with 8 gigs or less, is recommended for 1.5 times the amount of RAM, but we would say typically you'd probably want to go with twice the amount of RAM, and I'll show you what that means. Although Windows Server 2008 can expand paging files incrementally as needed, you'll want to size the paging file so that it is as large as it needs to be for average usage conditions. And those usage conditions change depending on what applications are installed on the server. If a server has multiple hard disks, you also have the option of putting paging files on other hard drives besides the C drive. So let's take a look at that. So if we stay in the exact same place we were, we just go ahead and click on the button that says Change under Virtual Memory. So virtual memory, what it does is when it runs out of RAM, it uses virtual memory or hard drive memory to do its calculations. So by default, you have the automatically manage paging file size for all drives. If you want, you can uncheck that, and you can click the system manage size, which basically it'll just manage the C drive. So instead of managing both like it will with them automatically set, it'll just manage it for the one. Then I can go in and set the same option for the other. The other options are no paging file, which we do not recommend, or the server will run so slow you wouldn't be able to use it. Or you could also choose a custom file. So if we have 2 gigs on here, then we'll probably want to say the initial paging size will be 2,000 megabytes, but the maximum is going to be 4,000. And before you click OK, you have to click the Set button. Otherwise, the changes that you just made will not stick. And if you change your mind, you want to let Windows automatically handle everything, just go right back to the automatic and click OK. Task Manager. It is the easiest way to track a system's general health. You can track running applications and processes and determine resource usage. Task Manager has 6 tabs. The Application tab shows programs that are running. Processes tab lists the image name of the processes running. And the Services tab, any services that are running. These are all tied together, which I will show you shortly. The Task Manager also has the Performance tab. The Performance tab is typically the one that you would go to see if the processor is getting pegged or all the memory is gone. Networking tab to see how much networking is being used, to see maybe you've got a virus on your computer is a good way to tell if your network is set to at 100% because all these viruses are using the server to send out the virus to other people. Then the Users tab shows you users currently logged into the system. Task Manager uses system resources while it's running, so make sure that you realize this. You don't want to leave it running all the time. When you're done with it, close it because it does use a lot of resources. The Performance tab should be the first tab you check if you suspect a performance issue. So let's take a look at that. Task Manager. We have applications running. You can see that the applications that I have minimized in the bottom here are showed at the top. And then you have the Processes tab, which basically shows all the executables that are running. Services show the services. It's the same services you would see under Administrative Tool Services. It's the same services here you would actually see here as well. These are sort of cryptic in the way they're named, so you have to look at the description and expand that. And then now you see this matches up to this. Performance tab, this is where you see how your processor or processors are running. If it's pegged at 100%, you know that you've got some sort of a problem, and you would go back to processes to click on CPU and see what's using all of those processes. You can also see how much RAM you currently have and how much is free. We can see that we've got 2 gigs of RAM and more than one of it's free, so this is actually running pretty optimally. But then again, we're not doing a lot either. And the Networking tab shows us how much network traffic we have, which we're currently not connected to anything, so it shows 0. Users shows that I am connected as the administrator to the computer. If anybody else was connected, you'd see that as well. So how they're all tied together, this is how it works. So if you see under Processes and Services, let's say one of your services is stuck in a starting mode. It's not running, it's not stopped, it's just starting or stopping. So you can't actually use it. In most cases, you would have to restart the computer in order to get that back to where you normally need to be. But instead, what you could do is locate that particular service, right-click on it, and choose Go to Process. Now when you go to Process, you can just see the actual process that that service is using. If you right-click and end that process, then you'll be able to see that the service will also stop. So that could save you from having to reboot your entire computer if you have a critical service that is stuck in the starting or stopping mode. And you can also do the same thing. You can also right-click on any particular process and go to that service. So it takes you back the other direction as well. So it's kind of a handy use for the Task Manager. And then if you want, you can also go to the Applications, right-click, and choose Go to Process. So it jumps right to the Processes tab. So if you have an application that's stuck, then you can also kill it by right-clicking on there and clicking End Process, and then it'll make the application go away. So let's choose Services for example. Right-click, go to Process, there we go, mmc.exe, and we're going to go ahead and choose to end it, and now it goes away. The Event Viewer Windows defines an event as any significant occurrence in the operating system. It's not necessarily all bad events. It could be just informational events that can be tracked, as well as events that record warnings, errors, and auditing. Critical errors that deserve immediate attention, such as when the servers run out of disk space or memory, are recorded in the logs, and they show up as critical. Windows logs that the operating system uses to record general system events related to applications, security, setup, and system components. There's also application services logs that specific applications and services use to record application specific. So, applications contain events logged by applications. Events in this log are for Exchange, SQL, Internet Information Services, and other installed applications. Also, you'll see events from printers. It has a 20 megabyte or 20 megabyte log file. This is actually off a little bit. 20 megabyte log file is the default, and then once you reach that maximum, it'll start dropping off with the oldest logs first. You also have forwarded events. When you configure events forwarding, this log records forwarded events from other servers. So you can have all the servers combined to forward to one server, which makes it real handy if you don't want to go to every single server. There's also setup logs, which record events logged by the operating system during installation or setup. So this was only used during that time, so it's not very useful after the setup is done. Security events, events that you've set for auditing with local or group policy. So I showed you how to audit hard drive access. Well, that particular access would show up under security. It also shows up every log on and log off attempt, whether it was successful. Only administrators are granted access to the security log by default. So if you want anybody else to have access to it, you'll have to manually add that access. The system contains events logged by Windows 2008 and its components. You need to routinely check for warnings and errors, especially those related to failure of a service to start at boot up, or the improper configuration of a service, such as putting in the wrong password. DFS replication and directory services, these are just two of the event logs if you have DFS or a domain controller running on a server. So actually see a special log just for DFS and just for domain controllers. If neither one of these are installed, then you will not see those logs. DNS Server is another type of, if you have a DNS server installed on your server like it is on all domain controllers, you're going to see DNS queries, you're going to see a log for that, as well as the file replication service. I've had many times where the file replication service logs told me that the domain controller is no longer properly acting as a domain controller, and I found that out by looking at the logs, and then from there I was able to fix the problem. Hardware events, I wouldn't trust this very much, but because there's not a lot of great interactivity between the motherboard and the operating system, but it can be useful for troubleshooting issues such as network interface card failures or hard drive issues when they do occur. But for the most part, hardware events is not going to be incredibly useful, but it is there. So Windows Server 2008 logs are configured to override old events, as I mentioned earlier. You can also have Windows automatically archive the logs if you want. You could configure logs so that Windows never overwrites events, but of course if you do that, eventually your server hard drive will fill up and crash. So there's different types of event log meetings. You have informational, which just generally relates to successful action. A warning describes events that aren't critical but could be useful in preventing future system problems. Errors indicate a fatal error or significant problem that could have occurred on the server, such as the failure of a service to start. And as I mentioned earlier, under the security logs, you'll see the audit success and audit failure anytime an auditing event happens. Archiving event logs allows an admin to save several months of log data. Using subscriptions and forwarded events, servers can forward specific events to a central event logging server. All right, so let's take a look at the event logs. Event viewer is what you want to open. And you've got custom ones, the basic Windows logs, and typically I'll go right to the system logs. If I have an issue, that's the first place I'll look, is the system logs. The second one is if it's just one application that's having a problem, but the rest of the server is running okay, then I'll go right to the application logs. Now, if I have a specific service, Windows service, such as DNS server problems, then I'll open up the application and services logs and click on the service I'm having an issue with, such as DNS. And from here, it'll tell me issues that may occur that can help me troubleshoot the problem. You can also right-click on any particular service, and you can go to Properties. And from here, as I mentioned before in the slide presentation, you can choose things such as override events, which is the default, archive events, so once it reaches the maximum log size, then it'll automatically archive them, or do not override events, which of course you have to clear the logs manually, but I don't recommend that as it will fill up the hard drive. Maximum log size is where you set that here, and then you also have the default location of where the logs exist. Performance baselines allows you to compare past performance with current performance. The types of baselines, we have post-installation baselines, which is a performance level that is meant to represent the way a computer performs after installing all the role services, features, and applications. Typical usage baselines is a performance level that is meant to represent average usage conditions and serve as a starting point against which you can measure future performance. It can be very handy to have that. A test baseline is a performance level that you use during the testing of a system. So if you're having an issue and you want to do a test, then you would do a test baseline. You should also collect several data samples at the same time each day over a period of several days to get an idea of what's happening with the server. You must work to keep the baseline in sync and how the server is being used. As you install new roles and new features, you're going to want to go in and do another performance baseline to see how it's performing. Performance objects represent any system component that has a set of measurable properties. A performance object can be a physical part of the operating system, a logical component, or a software element. So we're in Performance Monitor. These are the different things that you can monitor in that particular program. So the performance counters represent measurable properties of performance objects. For example, the percent of processor utilization, which is one of the default counters. In a standard installation of Windows Server 2008, many performance objects are available for monitoring. As you add services, applications, and other things, you can add more monitors. For example, DNS is one of the types of monitors. Performance bottlenecks. A bottleneck is any condition that keeps the computer from performing at its best. So if a system doesn't have enough physical memory or RAM, it doesn't matter whether it has a fast processor or a slow processor, the RAM is going to be the bottleneck. So Performance Monitor helps you figure that out. Performance counter alerts. This is one of the things you'll be doing in your lab. You can configure alerts to notify you when certain events occur or when certain performance thresholds are reached. You can send alerts as network messages and as events. You can also configure alerts to start applications and performance logs. The Reliability and Performance Monitor console. This is the tool of choice for monitoring a system's reliability and performance. It can monitor 4 different utilization categories. CPU shows the current CPU utilization and the maximum CPU. The disk shows the number of kilobytes per second being read from or written to. Network and memory. So let's take a look at the Performance Monitor. You can get there by choosing it from Administrative Tools or just typing perfmon. So there's our Performance Monitor. And we see something that looks a little bit like the Task Manager when you open it up. And by default, it shows the percent processor time. So this shows the same information you would see in Task Manager if you clicked on the Performance tab. So from here, we can remove different monitors. We can also click the plus sign to add monitors. So if we want, we can choose processor information. We can choose a lot of different things. And if we choose all those different things, we can go ahead and click OK. And now we see all these different processor monitors going on. You can see all these different colored lines. If you want one particular line to be highlighted so you can see what's happening, then you would just click this little pencil here and highlight, and you can see just that one. So it makes it a little easier to pick out if you've chosen a lot of different things. So you can see one of these particular processor monitors is pegging out. Now, it might mean that it is definitely being used at the maximum level, but it also might mean it's set to the wrong numbers. So you can right-click and choose Processor, and instead of the scale of being 1.0 like it is with the other ones, it may need to be set to something else. It may need to be set at 100. Or it may be set to less than 1.0. So it just depends on your particular needs, but it's all very customizable. Data collector sets, this will be one of the things that you're looking at. There's user-defined collector sets, which you create one, a custom one, or you can choose the system ones that are pre-created ones for you. And you can go in and add that and then create an alert that says when a certain threshold has been reached. So you will be working with the data collector sets in your lab. This is how you get there. You can create a new collector set just by creating new, go to that one, new data collector set, and then walking through the wizard, which the book will help you do. So in conclusion, we discussed performance monitoring, virtual memory, task manager, event viewer, performance baselines, and all the different performance monitor features, and reliability and performance monitor, which is part of performance monitor. That concludes Module 8, and we look forward to our final module, Module 9, in our next presentation.